Welcome back to the deep dive. We've got a stack of research today that covers something we usually take for granted until we really, really need it. The medicine in your cabinet.
Right. It's one of those things you expect it to work.
Exactly. You pop a pill, you expect it to make you better. But we rarely think about the massive, almost invisible engine that creates it. We're looking at a concept called Pharma 4.0.
Mm-hmm.
Now, I have to admit, when I first saw the title of the source material, this huge course on smart manufacturing and pharma, my brain went straight to corporate buzzword bingo.
It does have that ring to it, doesn't it? Sounds like the next iPhone update or something.
It does, but as I started digging through the curriculum, I realized this isn't just about, giving everyone on the factory floor an iPad. The source material is describing a desperate need to modernize an industry that is surprisingly, old school.
It's putting it mildly. You have to remember, pharmaceutical manufacturing is one of the most regulated industries on the planet. And for good reason, lives are on the line.
Of course.
But that heavy regulation, it often creates this culture of if it isn't broke, don't touch it. So you have factories running on these legacy systems because changing anything is a compliance nightmare.
So Pharma 4.0 is the attempt to drag that massive ship into the digital age.
Exactly. The source material defines it as the convergence of IT information technology and OT operational technology.
Okay, let's pause there, because the course makes a really big deal out of this distinction. ET meets OT. For anyone who isn't in this world, what's the actual friction there? Why do we need a special term for computers talking to machines?
Think of it as two different tribes that have, historically lived on different planets.
Okay.
The IT crowd, they're in the office, they care about data security, servers, email, the cloud. They move fast, they're patching software weekly. Their worst day is the Wi-Fi going down.
Right. And the other tribe.
Then you have the OT crowd. They're down on the factory floor. They care about the physical machines, the mixers, the tablet presses, the valves. Their priority isn't speed, it's stability and safety. If an IT server goes down, you lose email. If an OT system goes down or glitches, you might ruin $1 million worth of product, or worse, create a safety hazard.
So the OT guys probably look at the IT guys and think, keep your software updates away from my perfectly calibrated machine.
Precisely. It's a culture clash. Pharma 4.0 is about forcing these two tribes to speak the same language. It's smashing them together to connect the physical machinery to the digital network.
And the goal is efficiency, quality.
And, ironically, better compliance.
That's the big picture hook. But I want to get into the toolbox the source material provides because it's surprisingly specific. It starts with what they call the nervous system of the factory, the Industrial Internet of Things, or IIoT.
Right. This is the foundation. You can't have smart decisions without data. The IIoT is about placing sensors absolutely everywhere.
To get what the source calls a direct view of production.
Exactly.
The course lists some specific areas like API processing, injection workflows, and ointment workflows. Let's take the ointment workflow as an example. Why does making a tube of cream need the Internet of Things?
Well, think about how complex making a medical-grade ointment is. It's all about viscosity, temperature, mixing speed. In the old days, and frankly in many places today, the process is somewhat blind.
Blind how?
You'd run the mixer for a set time, stop it, take a sample, walk it to a lab, test it, and then realize, oh, the temperature drifted 3 degrees too high halfway through.
And at that point, the batch is just
ruined. You've wasted ingredients, time, labor, you're flying blind until the very end.
So how does IIoT change that scenario?
With IoT, you have sensors inside the mixing vessel streaming data in real time. You can literally see the viscosity changing on a dashboard. You can see the temperature curve second by second.
So if the temperature spikes, the system knows instantly.
And it can act on it. That's the smart part. But the source material highlights something even more valuable here. Condition monitoring of critical assets.
Which is just a fancy way of saying checking if the machine's about to break.
But doing it proactively. It's the difference between your car breaking down on the highway versus your car sending you a notification saying, hey, the vibration in the transmission has changed by 2%. Schedule service next week.
One is a disaster, the other is a calendar invite.
Exactly. In pharma, a breakdown during a batch of injectable drugs is a catastrophe. You often have to scrap everything and sterilize the whole room, which can take days.
Wow.
So shifting from reactive to predictive maintenance, it isn't just about saving repair costs. It's about making sure the drug supply doesn't stop.
That makes perfect sense. So all that data from the sensors, it flows up to what the course calls the brain of the operation, artificial intelligence.
Right.
And I feel like I can't open a browser tab without seeing AI plastered everywhere. But the source here gets specific. It talks about going beyond basic automation. What's the distinction? Is this just about robots?
No, and that's a crucial distinction. Automation is a robot arm doing the exact same motion 1,000 times. It puts the cap on the bottle. It's rigid.
So if the bottle is slightly out of place...
The robot might crush it. AI is about adaptation. It's about decision-making.
Okay, give me an example.
Let's stick with that ointment data. Automation runs the mixer. AI looks at all the data and says, the humidity in the room just went up, which is going to affect the curing time, so I'm going to slightly adjust the mixer speed to compensate.
It's analyzing variables that a human might totally miss.
Precisely.
Yeah.
It optimizes the process in real time. But the part of the curriculum that really caught my eye was the section titled, What Every Pharma CEO Should Know About Generative AI.
Yeah, I flag that too, because usually when we talk Gen AI, we're talking about ChatGPT writing marketing emails or something. Why does a pharma CEO need to care about that?
It's not about writing text, it's about simulation. The source describes using Gen AI to simulate supply chain scenarios. This is huge for leadership.
How so?
Imagine asking the system, what's the ROI if we switch raw material suppliers? But the new supplier has a 10% higher risk of shipping delays.
And the AI just runs that simulation.
It generates thousands of potential outcomes based on historical data. It helps the CEO balance cost versus opportunity. It moves decisions from gut feeling to data-driven probability.
That's the return on investment the source keeps mentioning because, and let's be real, implementing all this tech has got to be incredibly expensive.
Incredibly, and that's the tension. The source notes that calculating the ROI of Gen AI is tricky. You're spending millions up front to prevent problems that might happen in the future. It requires a bit of a leap of faith.
The source also mentions machine learning in drug discovery. That seems a bit further upstream from the factory floor.
It is, but it all connects. If you can use machine learning to predict which molecules are likely to work before you even mix a chemical, you save years of development time. And then you pass that data to the factory. It's a continuous thread.
This ability to simulate outcomes, it actually leads us to my favorite term in this whole stack, the digital twin.
It does sound like a sci-fi cloning experiment, doesn't it?
It really does. So in this context, what exactly are we cloning?
We are cloning the process.
Yeah.
A digital twin is a virtual replica of your physical manufacturing line. But here's the key. It's not just a 3D model you look at like a video game. It is fed by that real-time sensor data we just talked about.
So if the temperature rises in the real vat, the temperature rises in the virtual vat on my screen.
Instantly. They are tethered.
Okay, but why do I need a ghost factory if I have the real one running right in front of me?
So you can fail safely. The source connects this to digital customer order processing. Let's say a hospital system calls and says, we need a rush order of 50,000 units of this antibiotic due to an outbreak.
Panic mode.
Usually, yes. You'd have to guess if you can squeeze that in. With a digital twin, you feed that rush order into the virtual system first. You run the simulation.
And what does it tell you?
The twin tells you, if you do this, you will run out of packaging material on Tuesday, and machine B is going to overheat.
So you crash the ghost factory instead of the real one.
Exactly. You manage the uncertainty digitally, you tweak the schedule in the simulation until it works, then you execute it in the physical world. It just removes all the guesswork.
I want to pivot here because we're talking about all this sleek digital tech, but I know the reality in this industry is often paper. Just mountains and mountains of paper.
Oh, it is legendary.
I mean, the rule is if you didn't document it, it didn't happen.
That is the golden rule of GMP good manufacturing practice. A traditional batch record is a physical binder, sometimes hundreds of pages, that travels with the product down the line. People are signing off on steps with a pen.
Which just sounds terrifyingly prone to human error. Did I sign that? Did I actually add it? Is my handwriting even legible?
Or, I lost the page. And if you lose the page, that batch effectively doesn't exist. You have to destroy it. This is where Pharma 4.0 brings in EBMR's electronic batch manufacturing records.
The source calls this killing the paperwork. But surely it's more than just saving a few trees.
Oh, much more. It's about data integrity. That's a huge theme. When you digitize the record, the system enforces the process.
How so?
Well, on paper, I could accidentally skip step 3 and go to step 4, then realize my mistake. The electronic record won't let you. It physically locks you out of step 4 until step 3 is validated by the sensors and the operator.
That's interesting. So compliance isn't just a rule book you have to remember. It's baked right into the software code.
Exactly. And the source suggests this actually makes the FDA happier. They talk about FDA quality metrics. If regulators want to know how your process is performing, you just click a button. You don't need an army of interns digging through archives.
It turns compliance from a barrier into a feature.
That's a great way to think about it.
So we've got the smart factory, the digital twin, the electronic records, but eventually the drug has to leave the building.
Enter Pharma Warehouse 4.0.
The source brings up blockchain here. And again, I feel the need to be a little skeptical. Is this just crypto hype bleeding into another industry? Why does a box of pills need a blockchain?
It really boils down to trust. Counterfeit drugs are a massive global problem. In some parts of the world, a huge percentage of medicine is fake.
Right.
So the source describes using blockchain combined with RFID, radio frequency identification, to create this unbreakable chain of custody.
So you can prove exactly where that box has been every second since it left the factory.
And the conditions it was in. Remember, many modern drugs, like vaccines, are extremely temperature sensitive. With Logistics 4.0, you aren't just tracking location, you're tracking the environment inside the truck.
So if it gets too hot?
It's recorded on the blockchain permanently. The pharmacy knows instantly not to sell that box.
It sounds like a perfect ecosystem. But I suspect we're entering the reality check portion of our deep dive. The source material devotes a big section to challenges.
It does. It is not all smooth sailing.
Mm-hmm.
The biggest challenge is the one that keeps CIOs up at night. Cybersecurity.
That makes perfect sense, because now your mixer isn't just a mixer. It's a computer connected to the internet.
Your mixer, your ventilation system, your door locks. If a bad actor gets into a standard office network, they might steal emails. If they hack a Pharma 4.0 factory, the stakes are physically much higher.
They could change the recipe.
Theoretically, yes. They could alter the chemical composition of a drug, or they could just shut down production of a life-saving medicine and hold the company for ransom.
Wow. So you need a digital fortress, but who builds it? This leads to the other challenge the source is very blunt about: overcoming skill shortages.
This is the human bottleneck. Pharma has incredible chemists and biologists. Do they have incredible IoT architects and data scientists just hanging around?
Probably not in a biology lab, no.
No. And Silicon Valley is fighting for those exact same people. So the source highlights this massive skills gap. And it's not just hiring, it's culture. We go back to that IT versus OT clash. You need people who can understand both how to code in Python and how a tablet press actually works.
That sounds like a unicorn employee.
It really is. Finding someone who speaks both languages is incredibly difficult. It requires a whole new smart manufacturing mindset.
So leadership has to step up.
Absolutely. The source mentions the role of pharma CIOs and the challenges for CFOs. This isn't just a tech upgrade you buy off the shelf, it's a business strategy. If leadership doesn't drive that culture change, the technology will just sit there unused.
The technology is ready, but the workforce is still catching up.
That is the defining struggle of this whole transition.
So let's zoom out. We've gone through the sensors, the AI, the twins, the blockchain. What does this all mean for the listener? Why should they care that pharma is going 4.0?
Well, if we look at this so what here,
Yeah.
the source wraps this up with a section on driving smart decisions for a healthier future. For you, this ultimately means safer drugs, fewer shortages, and maybe even lower costs. But for the industry, it's about survival.
Survival. That
Yeah.
sounds dramatic.
The market is competitive. Regulations are getting stricter. The source argues this is critical to remain competitive. You can't run a 21st century drug company with 20th century paper records. You'll just be too slow and too expensive.
We're moving toward the factory of the future. Sensors in the press, digital twins on the screen, blockchain in the warehouse.
It's a comprehensive ecosystem. And it's fascinating to see how all these different disciplines, robotics, coding, chemistry, logistics, they all have to play nice to make it work.
It really is. Now, before we wrap, is there one final thought from the source material you want to leave our listeners with, something to chew on?
Yes. There was a section on intangible benefits that really stuck with me. We tend to measure success in hard numbers, right? Speed and cost. How much faster did we make the batch?
Right. How much money did we save?
Exactly. But the source suggests asking, how do you measure the value of agility? Think about a global health crisis like a pandemic. If your factory is smart and adaptable, and you can use digital twins to simulate new production lines in hours instead of months, what is that worth?
It's priceless. It's the difference between getting a vaccine out in a year versus 2 years.
Precisely. The source emphasizes continuous learning. In a world of AI and Pharma 4.0, the tech will keep changing. So the most valuable asset might not be the machine itself, but the organization's ability to learn new systems and just pivot really, really quickly.
That is a powerful thought. The technology makes you fast, but the learning makes you agile.
That's it.
Well, that is all the time we have for today's deep dive into the digital revolution of drug manufacturing. Thanks for listening, and we'll catch you on the next one.
Stay curious.